Greetings, Algebra 2 students. This is Mr. Weber here for our first virtual lesson. Today we're going to talk about converting between degrees and radians. Um, this is coming from page 363 to 374 in your textbook, so if you have any questions, you can go there and get some added resource. So on Edsby, you should see a notes page that's up there that's very similar to the notes pages we would get if we were in the classroom. You're also going to need a calculator. If you don't have a calculator, you can use an online calculator here at desmos.com. It's not the best, but it's better than nothing. So here we go. So the first couple slides I have are not on your note page. If you want to grab some paper and just write some stuff out, that's fine. But I think today's lesson is very easy in terms of what you have to be able to do, but it's less easy in terms of understanding what it is we're talking about. So I wanted to take a couple minutes and just go over real quick to make sure that it's very clear that you have a good understanding what we're talking about. Okay, so here we go. Imagine this. You might not know this, but I absolutely love tacos, and I actually love eating tacos from Capital Tacos. So if you haven't been there, I highly suggest you check it out. I looked at Google. It's 41-minute walk. If I were to walk from Bloomingdale High School to Capital Tacos, it's exactly 2.0 miles, and that's be about a 41-minute walk. So let's imagine for a second that I wanted to know how far that distance was in terms of kilometers. Well, to do that, what I would need to know is the conversion rate between miles and kilometers, and I do know that. It's 1.61. So what that means is that there's 1.61 kilometers in 1 mile. Okay, so if I wanted to convert this distance, 2.0 miles, to kilometers, all I have to do is multiply by that conversion factor. And if you can see, remember 2.0 miles, that's like 2 over 1. If I were to multiply this, miles would actually cancel out, and we'd end up with about 3.22 kilometers. Okay, simple multiplication. Now, here's my question. I just told you that it was 2.0 miles. Now I'm telling you it's 3.22 kilometers. Has the distance between Bloomingdale High School and Capital Tacos, has it changed? The number changed from 2.0 to 3.22, but has the distance itself changed? No. What's changed is the unit that we're using to measure that distance. All right, and that's what I want you to think about. So what we're going to talk about today is the difference in how to measure things on a circle. And the units that we use are going to be different. Okay, so let's think about a circle. When you typically think about a circle, you think about measuring it in terms of degrees. Think back to your geometry. How many degrees are in a circle? Let's think about that. We'll come back to it. So imagine I have two kids, Molly and Ben. Let's imagine I have a circle out in the backyard, and Ben's on the outside, and he's going to be running laps around the circle, and Molly's going to be standing at the center of the circle. Okay, so when you think about measuring a circle in terms of degrees, what you're really doing is trying to measure the distance on the outside, the distance that Ben runs, from the perspective of Molly being in the middle of the circle. All right, so let's imagine that Ben starts here right to Molly's right, and he runs all the way till he's right in front of Molly. So we can look at that and we can say, okay, if we look at where he started and where he ended, that would be like a 90-degree angle from Molly's perspective. She could put one hand where he started, one hand where he finished, and measure that angle, and it would be 90 degrees. And that's how we'd measure the distance. What we're measuring is not the angle, we're measuring the span of the outside of the circle. We're just using the angle as our unit of measure. Does that make sense? Okay, so if Ben were to run all the way around the circle, how many degrees would that be? Go back to geometry. 360 degrees. So you can see 90, 180, 270, 360, all the way around. Okay, now that's one way of measuring the distance around the outside of a circle in terms of degrees. But there's another way. The other way thinks about it from Ben's perspective. So Ben's running around in circles. How far is Ben going to run? Well, let's think about it. How do we measure the outside of a circle? What's that called? It's the circumference. Circumference is the distance around the outside of the circle. You're probably saying, I thought this was Algebra 2, not geometry. There's a lot of geometry today. So here we go. We're going to go around the outside of the circle. Let's think about what's the formula to find the circumference? No, it's not pi r squared. That's the area. Some of you thought you were really smart when you said that in your head. No, it's 2 pi r. So 2 times pi times the radius, that tells us how far Ben would run if he ran completely around the circle. Does that make sense? Okay, so here's my question. Let's say that Ben takes the same size steps every single time, and I want to measure how many steps he takes going around that entire circle. Well, the question is, depending on the size of his steps, will determine how many steps he takes around the circle. So to make it something that we can, that makes sense for all circles, we base it on the radius of the circle. So let's assume that we measure this radius of whatever the radius of the circle is. Remember, the radius is just the distance from the center of the circle to the outside. And if we measure that radius and we say every step that Ben takes is the length of one radius. If that's true, how many steps would Ben take? Okay, well, it's not as hard to figure out as you would think. We just take our circumference, which is 2 pi r, and divide it by the size of our steps, which in this case is the radius. Look what happens. The radiuses cancel out, and Ben would take exactly 2 pi steps. I know it's weird, it's a decimal, but go with it. All right, so we call this unit of measure the distance on the outside of the circle. That's the length of the radius. We refer to that as 1 radian. So we say that there is exactly 2 pi radians in the entire circle. Okay, now here's why this is so important. I'm sorry, let's go back and do this again. Let's figure out how far Ben would run. He started to the right, he ended to Molly's front. We said that was 90 degrees. Let's calculate how far it would be in radians. Well, where he's starting, he hasn't moved at all. So we're going to say he's moved 0 radians. If he goes all the way around the circle, that would be 2 pi radians. If he goes halfway around the circle, that's pi radians. Now look where he is right now. He is halfway between pi and 0. So we'll say he goes pi over 2 radians. We're always going to leave our radians in terms of pi. Don't ever put it in your calculator. Don't ever convert it to a decimal. Leave it as a fraction. Leave pi as pi. Pi over 2 radians. Okay, we're measuring the same distance. That's 90 degrees. Okay, but now we're measuring it not in terms of degrees, but in terms of radians. Hope that makes sense. Okay, so now let's think about how we go back and forth. Here's the great thing about radians. Here I have this small circle. It has a small radius. So if Ben's going to run around this circle, he's going to take small steps because the radius is small. How many steps would he take? 2 pi radians. If the circle's bigger, it has a bigger radius, all that means is Ben's going to take larger steps. And how many steps will he take? 2 pi radians. All right, so the great thing about basing a radian on the radius is that no matter what the size of the circle is, there will always be exactly 2 pi radians in the circle. So we'll always be talking about the same part of the circle no matter what the size is. That's important. Okay, so here we go. There's 2 pi radians in the entire circle. There's 360 degrees in the entire circle. Let's figure out some way that we can go back and forth between degrees and radians. Well, all we got to do is think about what we know. Okay, there are 2 pi radians for every 360 degrees. 2 pi represents 1 rotation around the circle. 360 degrees represents 1 rotation around the circle. But look, we can simplify. Boom. So we would say that pi radians is the same thing as 180 degrees. We can take the same thing from the degrees perspective. We can say there's 360 degrees in 2 pi radians. It's going to simplify. 2 divided by 360. 180 degrees is equal to pi radians. This is going to be our conversion to go back and forth. Okay, now we're ready for the notes. Converting between degrees and radians. Here's the easy part. To convert any degree measure to radians, you simply multiply by pi over 180. And then simplify. That's it. Done and done. To convert any radian measure to degrees, you simply multiply by 180 over pi and simplify. Done and done. Now there's a good part to this and there's a bad part to this. The good part is that these are so similar, you got to really remember one thing. It's pi and 180. The bad part is you got to remember what the order is. Does pi go on the top or does pi go on the bottom? Because otherwise you're going to mess it up. Okay, here's the easy thing to do. If you see a pi, pi's on the bottom. If you don't see a pi, pi's on the top. And when we get through those, it'll make more sense. Let's do a couple. Here we go. Convert each degree measure to radians, show your process. We're starting with 30 degrees. Okay, let's think about this. We're going from degrees to radians, so we've got to multiply by pi over 180. Again, 30 degrees, we don't see a pi, so pi is on top. That's going to be like 30 pi over 180, and then we simplify any way you want to simplify. Leave it as a fraction, pi over 6. Now, if you put this in your calculator and you try to simplify it, some calculators will simplify it for you. Other calculators will take that pi and convert it to 3.14, blah, 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 and give you this crazy decimal. All right, so one way you could do it in your calculator is actually to leave the pi off, and in your calculator, just put 30 divided by 180, and let the calculator simplify that fraction, which is 1/6, and then put the pi in the numerator at the end. So it becomes pi over 6. Okay, let's try another one. Number 2. 100 degrees. Going from degrees to radians, multiply by pi over 180. So we get 100 pi divided by 180. Simplify. 10 over 18, 5 over 9. Done and done. Remember, the great thing about watching videos is you can always pause it at any time to go back and go forward. I'm going to recommend right now that you pause and try number 3 and number 4 on your own, and then come on back and we'll see how you did. All right, here we go. Number 3. 225 degrees, multiply by pi over 180. So it's like 225 pi divided by 180. Now to simplify, we're going to divide by 5, top and bottom. 45 pi over 360. And then we can simplify that either in the calculator or we can divide the top and the bottom by 9. And we get 5 pi over 4. Did you get it right? Number 4, 280 degrees. Multiply it by pi over 180. 280 pi over 180. I always like it when they both end in 0 because you can divide the top and the bottom by 10, and boom, those zeros are gone. 28 pi over 18, 14 pi over 9. Leave it just like that. Don't convert it to a decimal. Don't worry about being a crazy fraction. Radians are almost always fractions, so you're good. Okay? What if we have a radian and we need to go 2 degrees? See how that works. So convert each radian measure to degrees and show your process. So we're starting with 2 pi over 3. Now, remember what I said. If you see a pi, pi goes on the bottom. Okay, so instead of multiplying by pi over 180, we have to multiply by 180 over pi. Okay, so 2 pi times 180, 3 times pi, multiply straight across. And look what happens. We're going to have a pi on the top and a pi on the bottom. So not only can we just divide 360 by 4, the pi's are going to actually cancel out and they're gone. And that makes sense because degrees don't have a pi. 360 divided by 4, 90 degrees. Boom, done and done. Number 6, pi over 4. This is in radians. We're going to degrees. We're multiplying by 180 over pi. There we go. So we get 180 pi over 4 pi. Pi's are going to cancel out again. 180 divided by 4, 45 degrees. And again, if you need to pause at any time, go for it. I'm going to ask you to pause right now. Try 7 and 8 on your own, and then come back and see how you did. All right, here's number 7. 10 pi over 9 multiplied by 180 over pi. Pi's on the top, so I got to multiply with pi on the bottom. I get 1,800 pi over 9 pi. And then divide your numbers and pi. 200 degrees. Number 8, 7 pi over 20. Multiply by 180 over pi. Multiply straight across, 7 times 180. 1,260 pi over 20 pi. Okay, pi's are going to cancel out. You get 1,260 divided by 20, 63 degrees. So far, so good. Awesome. All right, here we go. That was it for the day. Here's our summary. We got to convert from degrees to radians and from radians and degrees. First thing, you should know what a radian is. We're trying just to measure the outside of the circle, and we can measure that outside of the circle in terms of degrees, like we're used to doing, or in our new unit of measure, radians. Remember, we're not talking about a different size of the circle. We're just measuring it differently, the same way that we measured the distance from Bloomingdale High School to Capitol Tacos differently, whether in miles or kilometers. It's a different unit of measure, but it's talking about the same distance. Degrees and radians are different units of measures, but they're trying to talk about the same distance, the same part of the circle. All right, so if you're converting from degrees to radians, you're going to multiply by pi over 180. And the way I remember this is that if you don't see a pi, then you multiply by pi. Pi on the top, pi over 180. Converting from radians to degrees, we're going to multiply by 180 divided by pi. If you see pi in the radians, then pi needs to be in the bottom of the conversion. Okay? If you have any questions, please reach out to your teachers. Try to complete that assignment page as well, and we'll be here if you have any questions. Have a great day, guys.